basics of deep learning with an exciting project of building an artificial neural network to predict the mileage of cars. The goal of this video isn't to create a perfect model, but to help you learn the step-by-step process of using TensorFlow and Keras to build and train your own ANN model. By the end of this video, you will have a solid understanding of how to process the data, design a simple neural network, and evaluate its performance. So let's get started and see how powerful and easy it is to work with neural networks. So this is the Kaggle dataset which we are going to use for our model prediction, for our model training. So this data is Autompg dataset, which consists of some rows and columns. We have MPG, cylinder, displacement, horsepower, weights, acceleration, model year, origin, and car name. These are the columns that our dataset have, and this is the dataset. You can easily find the dataset on Kaggle. So we are going to use this dataset for our model, and we will write the code and understand the code step by step. So let's get started. I have created a new Jupyter notebook, and let's name it ANN model. Now our first step is we'll import the necessary libraries for data manipulation, scaling, and building our neural network. So let's do that. So here we have imported all the necessary libraries. Let's run this cell. It will take time. So now let's load our dataset. We have downloaded this dataset in our system, so we can directly load it from pandas. So we just have to make a variable called data and write pd.read csv, and here we have to pass our data path. So let me copy it and paste it here. So our data is in data variable now. Now let's check out the first few rows of the data to understand its structure. So we will write data dot head, and let's load 5 rows. So these are the columns of our data set. So as you can see, we have MPG, mileage, our target variable, cylinders, displacement, horsepower, weight, acceleration, model year, origin, and car name. So we are not going to use all these columns, but we will use few columns because our end goal is to learn how to use ANN and how to code ANNs. So let's uh, let's get a summary of the data set to understand the types of column we have. So to get the summary of data, we just have to write data.info, and here we have the summary of data. So as you can see, these are the data type of every column, and this is showing that if our column have any null value. So no, we don't have any null value in our data, and we have float, integer, and object type of data in our data set. So now let's check if we have any duplicate row in our data. So to check that, we have to write data.duplicate, data.duplicated, and to check full data, we just have to write sum. So yes, we have 0 duplicate row in our data. Now as you can see here, we have MPG, cylinder, displacement, horsepower, weight, acceleration. So we have too much columns here, so we are not going to use every column. So we have to remove some columns. Some columns like car name, origin, model year, acceleration aren't useful for predicting mileage, so let's drop them. So to drop the columns, we have to write data dot drop, and here we have to pass the columns, and we'll pass columns in a list. So here we have to pass the names of the columns which we want to drop. So I will copy and paste it here. So we are going to drop car name and origin and model year and acceleration. Acceleration is not useful for predicting mileage. Actually, it is not that impactful for predicting, so we are dropping this, and we have to write in place equal to true, because want to change these permanently. So, yeah, now our data only have these column: mpg, cylinder, displacement, and horsepower, and weight. So now let's check maximum horsepower that we have in our data. So data power dot max. Okay, so it is showing some unexpected character in the data. So it looks like horsepower column has some garbage string value in the data. So to remove that, we have to write data equal to data, and here we have to pass the name of the column horsepower, and we have to check if the value of the column horsepower is not equal to this character question mark, then we have to place this in our data. Uh, so by this code we will remove all the special characters in our data which is in horsepower column. So yeah, we are done with that. Now let's check HP. Now let's store this data in HP variable. Data HOR is horsepower. So let's convert it from string or object type to what's the type of horsepower? It's object type. So we have to convert it from object to integer to check the maximum integer value in the data. So to convert, we will simply write as type, and pass the integer in here, not in single quotes. Simply we have to write int, and it's running. So to check maximum, so it is throwing some kind of error. HP data dot s type horsepower spelling. So it is basically saying we don't have any horsepower column in our data. So here we haven't added this column in our data. So to add that, we just have to write this like this, and data. If data is not equal to this special character, then store the horsepower in data. So it is again. So we'll run this code from starting, and now the error is gone. So we have stored our horsepower without this character in data variable, and now we have converted it from object to integer type. And now let's check the maximum value of horsepower that we have in our data. So hp.max. So we have maximum 230 horsepower in our data, which is very low. Mm. So we don't have to do anything with data. We just trying to learn how to build ANN model from scratch with TensorFlow and Keras. So as our next step, let's take a look at the statistical summary of our clean data. So to do that, we just have to write data.describe, and enter. So we have mpg, cylinder, displacement, weights, these columns, and this is the statistical architecture of our data. So now, next step, we'll separate the data set into input features, which we'll call X, and target value, which we'll call Y. Target values are basically values which we are going to predict, and X is the input variables that we will take as input to train our model. So to do that, we just create a variable X and pass. We'll drop mpg, the target variable, and store everything else in X variable. So data.drop, and here we have to pass column name. Columns equal to, just have to write mpg. So we'll drop mpg from our data. So we have input variables, and now to get our target variable, we will store target variable in y, and our target variable is mileage, which we are going to predict. So here we will simply write mpg. So we have our target variable also. Now we will scale and normalize the data. So to uh, do that, we will use a min max scalar class. So we have imported min max scalar class, and now we just have to create object of min max scalar equal to min max scalar. So we have created an object of min max scalar class. Now we just have to pass our x in this. So to do that, we just have to write x scaled or x normalized. So x scaled equal to scalar dot, we have a function called fit transform, fit transform transform, and we just have to pass our input variable here, and so this will scale every value of input variable and store in x scaled. So now we have our target variable x scaled, scale target variable, and no y as target variable and x scaled as our input variables. So now we will split our data into training and testing, and keeping 20% data for testing phase and left 80% as our training data. So to do that, we just have to write x train comma test comma y test y train comma y test y train comma y test equal to train test. We have imported train test split, so we just have to pass this in our train test split. We have to tell that we have to pass our scaled variables, scaled x scaled and target variable y, and here we have to tell that what will be our testing size. So our test size should be 20% of our data, so 0.2 and random state will be 42. Okay, so now we have successfully splitted our data into testing and training phase. So we have x train, x test, y train, and y test. So now it's time to define our neural network model using the sequential API. So let's start by adding layers. So first we have to uh, create a object of sequential class, or we can directly add layers in sequential class. So model equal to sequential model equal to sequential, and here we will directly add layers. So the first layer is the input layer with 128 neurons and ReLU activation. So to add input layer, so basically we can add ANN or neural network layers by just using dense. So it will take first it will take the number of neurons. So number of neurons should be 128, and it will take the input dimension or the input size which it expect to from the data. So the input size should be input input dimension should be equal to x train dot shape. So x train dot shape, and the activation function that we are going to use is ReLU activation equal to ReLU. And so next we add a hidden layer with 64 neurons also using ReLU activation. So we'll again write dense, and here we will pass the number of neurons which is 64, uh, and activation as ReLU, and another hidden layer with 32 neurons and ReLU activation function. So dense 32 neurons and activation function equal to ReLU activation function equal to ReLU. Finally, we add our output layer with a single neuron because it is a regression task. So write dense one neuron with activation function. Here we will use activation function as linear because this is our output layer. So activation equal to linear. So this is our ANN model. We have four layer here. The first is input layer with 128 neurons and ReLU activation, and second layer with 64 neurons and ReLU activation, and third layer with 32 neurons with ReLU activation, and we have our output layer with one neuron with activation function equal to linear. So this is the model, and as we have very less data, so this is not the perfect model, but we are going to use this model. So this is the basic idea of creating the model with TensorFlow. These layers, these are artificial neural network layers, and which is called dense in TensorFlow. and this is the sequential. What sequential do is it pass the output of this layer in this layer sequentially in every layer. Output of every layer will be passed in the next layer sequentially. So this is the sequential model. And now let's take a look at the summary or the model's architecture. So to take a look at the summary, we just have to write model dot summary, and it will give the summary of model. So here we have 128 neurons, 64 and 32, and we have output layer with one neuron. So here are the total trainable parameters, and here are non-trainable parameters. So we have 11,009 trainable parameters. Now we'll compile the model with Adam optimization. So let's compile. So model.compile. So optimizer will be Adam optimizer equal to Adam, and here we'll pass learning rate equal to 0.001, and also we have to pass a loss function here. So mean square error, we'll take mean square error as loss and MAE as a matrix. So loss equal to mean square error. So we'll just write mean underscore squared score error, and at the end we have to pass matrix which is our MAE. We'll compile this. So it is giving error trainer.compile unexpected matrix. So it is matrix. So here we go. So our model is compiled, and now we can train our model. We'll use 20% for training, and 20% of training data as validation data, and not training but testing data as validation data, and other 80% as training data. So we'll store the output of every training epoch in history variable so that we can plot a graph. So history equal to model.fit. So here we are fitting in the model. So here we have to pass our trainable parameters. So input variable, sorry. So input variables and target variable, and validation split would be 0.2 or 20%. Validation split equal to 0.2, and number of epochs. So number of epochs means the number of iteration we want on this data, on of this model. So we'll take number of epochs as our data is less, so we can run 200 epochs easily on the data. So we'll take 200, and batch size will not upload full data in memory directly, so we'll pass the data in batches of 30 to 32, and here we have to just write verbose equal to 1. So it is also unexpected or epoch, it's epochs. So as you can see, our training has started, and it is going very fast. So it will take time. So here we go. So we have completed 200 epochs here, and once the model is trained, we'll use it to make prediction on the test data. So to make prediction, we'll just write uh, prediction equal to model.predict, and here we'll pass our testing data x test, and here are the first 5 prediction made by the model. So we'll print the first 5 prediction. So print prediction, and first 5 prediction of our data. So these are the first 5 prediction made by our data, made by our model. So our model is performing pretty decently because we have less data, and we have made our model very complex. We have used 128 neurons and 64, then 32. We have total 11,000 parameters, trainable parameters. So you can change these things. You can experiment with these things and make your model to perform more frequently and more better on the testing data. So to understand how well the model performed, let's plot a graph between training and validation loss. So as we have stored our model history in this history variable, so you can easily plot the graph. Plot the graph, we just have to write plt dot plot history dot history loss. So this is our training graph. So as you can see, validation and training loss are going together, so it is good for our data. And you can also experiment with the data, with data and model to make it more make it more better and make it more powerful. So lastly, we'll calculate the additional performance matrices like mean absolute error, RMSE, and R squared error. So to check those, we can easily write MAE equal to mean squared error, mean squared error, and here we have to pass y test and ypred, y test, comma ypred. So this is our mean absolute error and RMSE and R squared error. So this is how you can see the error matrices or error score in ANN. And so that's it for today's video, guys. We started by understanding the basics of building an artificial neural networks using TensorFlow and Keras. Along the way, we learned how to process the data, design a neural network architecture, and train it on a data set and evaluate its performance. So the goal wasn't to create the perfect model. So we haven't created a perfect model, but to learn and give a strong foundation to start building and experimenting with ANN models. If you found this video helpful, don't forget to hit the like button and subscribe to the channel for more beginner-friendly deep learning tutorials. Let me know in the comments what topic you'd like me to cover in next video. If you have any question, I'd love to help, and comment below for the questions.